Welcome everyone to another quick security debriefing here live on our channel. I hate to be proven right, but for all those subscribers and commenters at times believing I don't know what I'm talking about after 25 years in the industry, it's finally official. Google security blog learning from KCTF VRP's 42 Linux kernel exploit submissions. Google running this vulnerability rewards program to support researchers evaluating security of Google's Kubernetes engine, GKE, and the underlying Linux kernel. And it is absolutely mind-blowing and crazy. I multiple times pointed out here in my previous more regular weekly or so security debriefings that probably we should do more often, or otherwise just while we will develop our Linux distribution here. Going over, subscribers often see me going here over checking for derefs, null pointers, oops, crashes and reverts and stuff, and very often we have seen iouring. Iouring, for those who are new to this stuff, is a new high performance, because obviously the only substitute for performance is more performance. A complex mechanism of not having one system call. Usually we have one system call, whether that's an old software interrupt 80 hex or new system call. This enter all the risk variants thereof of changing execution from unprivileged user space contexts to the kernel for open, read, write, and so on. And what iouring does is allowing to group those, vectorize that. I personally proposed vector system calls. I was only thinking of a bunch of them, like having like a group here, like 8 or so syscalls of open, read, write, whatever. And so an even more complex implementation it became, while somewhat innovative, allowing a ring buffer. And so not a fixed set, and also it doesn't require signaling anymore, so you have one huge ring buffer. Like if you, like optional, right? Like if a high performance web server database and other such storage stuff opts to use it. So you do iouring init, have a 4K or whatever huge ring buffer, and the user space application writes basically system call information in there, and the Linux kernel processes asynchronously. The huge benefits of this are, of course, no individual one at a time context switching, also for nowadays method threaded, hyper-threaded CPUs. There are actually most of the time no context switching, certainly leaning a magnitude or more performance of the user space application writing into the commands into the ring buffer. And the kernel, usually even on other CPUs, allows to asynchronously process those, and resulting in a very high performance system call replacement. Something as amazing that the Redux Rust operating system people want to implement something similar. Now the problem with, of course, with complexity is the devil is in the detail, and that is even I noticed, and I for sure pointed out 10 times over the last years. It's like, because each time when I like casually review this here, 10 times I pointed out use after free, null pointer, logic checks, and so on. Like even I realized without the $1 million security research, like wait a second, every other major kernel release we have here major bugs and security vulnerabilities in this highly complex code, which, so spoiler alert and recurring reminder, you probably don't want to have a single address-based monolithic Linux kernel in today's insecure Wild West internet. Linux found now that just in last year, 2022 or so, just a little bit surrounding gossip here, underlying Linux kernel. So they extended this VRP scope for maximum reward in 2021 to 50K, then again in February 2022 to 91K, and finally in August 2022 to a whopping 133K. Yes, that means when you're, instead of doing this unsuccessful open source work where nobody pays you, you just do security research and find other people security bugs, logic bugs and use after free and stuff in the unsecure, that is a C language, you can easily earn a whopping 133k at a time. In 2022, they summarized the learning data in their cookbook and introduced experimental mitigation, most common exploit techniques. In this post now, they share their learnings and statistics about Linux kernel exploit submissions and how effective their mitigations are against them and protecting their users. Finally, how the changes in programs. So learning statistics, here also soon 2 million or so paid out. What do they write here? 1.7 or so millions paid out or whatever. And absolutely staggering, since the interception has rewarded, here it is, reward research a total of 1.8 million US dollars. And in my opinion, this is also, I mean, it is a double-edged sword. In one way, it is of course good to improve open source Linux security, but the thing I hate with that is, and why I personally do it a little bit differently, we of course in T2 with our major Linux distribution have something, also what I usually do this, wait a second, because usually when I do it live on YouTube, GitHub asks me to confirm my mobile number. So I do it differently in our high-profile Linux distribution for embedded and enterprise Linux use, because I know that all the C code is insecure, which, spoiler alert, I'm not a fan of that for 15 years, and I also don't like. I mean, I'm not yet billionaire to pay for other people's security vulnerabilities, right? And I also don't like. Well, I applaud Google. It's obviously a great thing and investment of money. But the problem is that people who do all the hard work are not paid for that, right? Sure, Jens Expo and stuff, they work at Facebook or so. But otherwise, a lot of people do all the hard work are not paid for their work. So we pay for bounties. Yes, we are a growing incubating project, right? The more you shall subscribe, the more we grow. You use T2 for all your professional embedded and board support package and stuff. The more we can afford it, but hey, we pay up to $100 for features, and many of them are small, right? So if you're a student or live in developing countries, you probably can even make a living out of implementing T2 feature bounties, which I like much more. As much as security research and payments are needed, I find it much more fair to directly pay the people who are actually implementing new stuff. Coming back to this issue, right? So they found that they paid 60% of the submission exploits using the iouring component in the Linux kernel. And so they paid out around $1 freaking million US for iouring alone, right? And so that is the disconnect. And I always said this, right? And people always hate me for that. I'm not only the messenger, right? I have 25 years of experience, which, spoiler alert, which most professionals in the industry probably agree, that too much stuff is buggy, right? People fabulate about not liking perfect code on YouTube, previous live stream. I and security researchers love perfect code, right? Because what's not perfect is freaking broken, or just, you see that here, right? And that I'm often negative is just the result of 25 years in the industry, including Linux kernel and security related things. And it's obviously mind-blowing that 60% for a component. Yes, I agree. I just recently said, they see I'm not even overly negative. I even recently praised iouring as one of the biggest innovation of the Linux kernel, because we discussed once or twice not only my opinion that the Linux kernel, or better Linux and the 2000 Linux distribution hinder OS research, because everyone just does another Linux distribution because people don't have the courage to start a whole innovative kernel from scratch anymore. And they just do another Linux distribution with a little bit different packagement, a little bit different security or stuff. And yeah, 60% and people do Linux distribution and don't look into security research. And so iouring is in Linux kernel, in Linux news. Linux news websites and YouTubers praised as it's the best invention in sliced bread, and always say, hey, I don't even like sliced bread, right? Because sliced bread dries out quickly. I don't even like it. Those inventions, like, yeah. So, but even because recently I mentioned in some other YouTube live stream or video that there are not even that many innovations in Linux kernel. Basically, it's just a clone of Unix, right? And it's not even microkernel. And yes, performance. But hey, that is what you get from performance, right? Not only a inherently insecure single address-based monolithic Linux kernel, where if you have a security vulnerability in your USB stack, you can break into all the other subsystems with a malicious USB device, HID device, right? You just plug some USB device into, like, yes, physical access and it's insecure. However, certainly the same goes for networking. Yeah, if you have no line of defense, if you have everything in one address space, yes, I know performance and microkernel complexities, but anyway. So this stuff is so insecure that Chrome OS disabled iouring. I just looked into that, however, and one thing that is not the most amazing, did I just close that here? That was very clever. Why did I close that? Actually, I wanted to show something. Where do I have this? As usual, amazing preparation here. Because the thing is, I wanted to disable it, but it turns out that iouring is an expert option. So what it means is you don't have it in a regular menu config and you need to enable config experts, and most people don't even do that, right? Because I wanted to quickly disable that, it's not like, yeah, we don't even. So the thing is, most things don't use it. You would need a high performance server, IO, whatever stuff. Yeah, I wanted to disable that too. But so the problem is with disabling the expert options, then without all the automatically enable disable stuff, we might actually change some other expert options that we might. I would need to quickly run that. Of course, it's not the biggest deal, but I mean, maybe iouring maybe should not have been hidden behind expert options. It's like, yeah, one of the most vulnerable components of the Linux kernel, you first need to enable expert mode to disable it. Anyway, Android seccomp BPF filter ensures that iouring is unreachable to apps, so like regular App Store apps, and only available to system components. Future Android releases will use SE Linux to limit iouring to selected few system processes. KE Autopilot, they investigate disabling iouring by default, and it is disabled on Google production services. So who cares says iouring remote vulnerability, not who cares. Yes, I thought so. The same is, after all, maybe I'm not disabling it now in our increasingly popular Linux distribution, because performance. It's like, hey, after all, you've chosen a single address space monolithic kernel, then it's like you performance you get, but not security. It is true, however, if you have other users or like on virtual hosting and stuff, you could still like if you are a hosting provider or you host others' applications, you're some kind of business who provides business services, web services, tax accounting or whatever other such stuff, it might still be exploitable by gaining local access in some way, shape or form, and then potentially using iouring to elevate your privileges. Any case, while Google concludes here, iouring brings performance benefits, but again, like, it's not like you're probably using it, right? Like, there are very, very few applications probably using it, but it also shows you need to be careful, right? I'm somewhat mind-blowing that this Jens Expo and their surrounded team and working at Facebook, they kind of should know better. And like, after the first handful of security vulnerabilities, you would have thought that they put some more thought into security. and unit testing or static code analyze that better, or just guru meditate that, and like after the first 1 to 3 or let's say 5, half a dozen or so I give them, they would implement means to prevent security vulnerabilities in the future. But the thing is, of course, the other thing is not only the only substitute for performance is more performance, but also in the Linux kernel, I regularly criticize that they change so much, right? So sure, they change because like often they also just rearrange stuff, break our precious SGA Octane, P3, you name it. But also, like even if iouring might have been reviewed and be secure last year, they change and innovate and more performance and restructure and improve and more asynchronous and more parallel and new features and stuff. And of course, with only constant is change is regressions. So while there are some benefits, promptly reacts to security issues with comprehensive security fixes, backporting to 5.15 version to the 5.10 stable tree. It is a fairly new part of the Linux kernel as such, but I would still argue, like this is also why more and more people certainly move to Rust, although I should say Rust is not 100% secure, right? Because you can implement logic bugs the same, so even if you memory access stuff, you might not have use after free or similar such classes of errors in Rust code, but you still might have other logic bugs, right? Like if you have UID check, like you forget UID checks or other stuff, like unless you have some generic frameworks in place. So you can still, of course, make all the other classes of classic logic and such related programming mistakes, or simply write wrong data to the wrong structs and stuff. So it's not like just moving to Rust would eliminate 100% of all bugs and security vulnerabilities. I would also argue that even if it's a new component, like if you put something in a world-class, like most used kernel for all internet servers and Android and so on, and some desktop users, it like if it would have been at Sun Microsystems or SGI decades ago, you would hope it would be a little bit more researched and years put into better testing and thorough security review before shipping it in production, and which is probably good advice also. Like if you run Linux kernel stuff in production, you probably want to disable new features for some years until the usual avoiding version .0 and like only enabling it and shipping it with version 10 or so. Yeah, still affected by severe vulnerabilities and also provides strong exploitation primitives. For these reasons, they are currently considered safe only to use by trusted components. One quick check to the comments, of which we have a few. Otherwise, I hope you enjoyed this and learned something. Don't forget to share, like, and subscribe, and have a good day or night wherever you are. And we also have Patreon and YouTube membership. And otherwise, we'll also continue to work on new microkernel components for a safer and hopefully more bug-free computing future. More comments there. Still care local security, just less important. Depends what use case. Desktop users who run Linux without spectrum mitigation. Some security stuff just an art. Well, in a lot of Spectre and Meltdown stuff is also exploitable by websites, right? That is, of course, with all web USB, web serial, web MIDI, web graphics and WebGL and stuff. It's like, yeah, you don't want to, like with the latest and greatest Ryzen and so on, the mitigation impact is not even that large, if much at all. So I would, in this day and age, I would not use an old browser and not disable security mitigations even on Linux desktops. And Anon writes, maybe they should rewrite it in Rust and fix all their issues. Yeah, I don't think that will be any rewrite in Rust soon, but if you're looking for something like this, then probably what we reviewed, Redux OS, is probably for you. And they had some Summer of Code project to implement some iouring equivalent as well. I'm not sure if that is, I think that happened maybe, I'm not sure if it's merged yet or how successful that was, but yeah. And then writes, imagine need some unsafe blocks and writing kernel level. Yeah, and you, as I said, you still can have logic bugs, right? So some additional static analysis and guru meditation is required for Rust code too. And yeah, that's it. That were the comments. As usual, don't forget to share, like, subscribe, and I hope to see you soon for the next security vulnerabilities. And leave in the comments below if I should continue what I've done the previous years. Actually, my New Year resolution, among other things, was to reinstate the weekly security debriefings. Leave in the comments below if I should do this every weekend or so. And otherwise, see you soon for the next video.